Now, as you mentioned today we wanted to make a webinar because of this. Okay, Siddharth is saying that the voice is breaking, but maybe if you have any issues, technical issues, what you can do is you can refresh this page, and then it depends on your internet connectivity as well. But as far as I can see from the messages, most of our attendees don't have any problem. So we wanted to make this webinar because obviously we are all locked down at home, but also we thought that, you know, we can start a series of webinars about jewelry manufacturing and using 3D printers. So what I'll do today is speaking about all those topics, and please ask all questions that you may have. Now, I want to just briefly give you an overview of our company, because some of you know us, but some of you may be just discovering. So we are a Turkish company that was created in 2013, 7 years ago. And our main job is to manufacture, firstly, resin for 3D printers. So we have different resins for jewelry, but also for the dental area for various 3D printers. And we manufacture also, as you may know, 3D printers for jewelry. Our team is made out of more than 50 engineers, chemists, and customer support technicians. And, you know, when I look to our company, our know-how is mainly mixed in three segments. First of all, we do a lot of R&D for 3D printing. We work on the material and the chemistry side, and also we put those two knowledge together in one particular area, which is jewelry or dental. We don't do any other areas than jewelry or dental. So we are not interested into prototyping for industries and so on. As you may know, we have our headquarters in Istanbul. It's in the Asian side. We have also sales offices in Istanbul in the European side, in the jewelry center. We have an office in Dubai that takes care of the Middle East area, and we have also another office in Adana, which is east of Turkey, for the dental area. Now, if you wonder where you can have more information about our brand or our products, there is novafab.com, which is our jewelry website, and powerresins.com, which is our resin website. We have also another website, dentafab.com, which is related to dental. Okay, let's go briefly through the 3D printing technologies that are used mainly for jewelry. I know most of you knows all those technologies, so I will be very brief on that, and then we can go into more details in some of them. So I put here mainly 4 technologies that were developed in the last 20 years, and we can call it jetting, SLA, LCD, and DLP technologies. Now, if we look about the jetting technologies, the way it works is that you have 2 material that are jetted on the surface using, so basically you have those 2 heads that sends these materials, and one of the material is the main building material of the jewelry part, and the other one is the support part. So in that picture, the white part is the support part, and the blue or purple part is the main jewelry. And once it's jetted, there's a UV lamp that cures that jetted part. So in essence, they are using also a similar material that is a sort of resin that cures with the UV. Now, if we look to the pros and cons of this technology, first of all, jetting is quite high resolution, and we see it as ideal for making master molds because basically the con side of it is that it's quite slow. So you wouldn't, we have some customers, I think, that are using this technology for direct casting in gold, but mostly because of the cost of the material, because of the prints that sometimes have issues in terms of solidity and they are breakable, they mainly use it as a master model making. And we have seen in the last 20 years when people were developing these technologies that the jetting heads can have some technical issues. So you may have some issues when using these dual jet systems. I just put here briefly how the rubber mold making is made. So you have a 3D design, you print with a jetting printer like the Projet 3D printer. You can cast it in silver, and then you take a rubber mold from that silver polished part, and then you inject the wax to cast in gold. So that's let's say a 6-step It's a 6-step production, yeah. Another technology that is widely used is SLA technology. Now, basically here what you have is a laser beam that by using galvos and mirrors, you change and move the laser where you want to cure it. So it's like drawing with a pen on the parts that you want to cure. Now, that can be also quite high resolution if you have a very thin, tiny laser. But some less commercial or cheaper version has used, let's say, low quality laser, and these lasers may be quite thick. The other advantage of it is also that you can have quite a large build size. So because the laser can go everywhere, you can go up to 300 millimeters build size platform. On the con side, I see this also laser technology that is very slow because the laser has to go through all the areas that it has to cure. And because you are using mirrors and galvos, you may have some issues when those mirrors gets dirty. So the laser may be deflected in a way that basically you need to clean the mirrors quite frequently. As you may know, there is like 2 major brands in this area. One is DWS, and the other one is Formlabs. So the other technology that I want to mention here is the LCD technology. I call this LCD because basically you have a light source, which is an LED. It's a UV lamp. It's a UV LED, sorry. And that LED on the bottom is filtered using an LCD screen. This is an LCD screen that are used like on the mobile phones, and it lets the light pass from only the areas where it needs to cure. Now, the good thing of this technology is that it's quite cheap. It's I would call a good DIY solution. But on the con side, again, because the LCD screen is filtering around 98% of the light, what happens is that there is only a very small amount of light that passes through the LCD. So because you have a low light intensity, the technology of curing is quite slow. And the other drawback is that the LCD can get damaged from the UV light. So the crystals inside the LCD screen gets damaged, and you have to change it, let's say, every week or once a month, or depending on the usage that you are making, whether you are using it 24/7 or just making few prints, you may have some issues. The other drawback also, as you may see, the light source is in the middle. So what happens is that the light is not really uniform most on the corner and the middle side. So you may have more light in the middle and less light in the corners. I will show you an example of what this means in terms of curing the material. The other technology that we are going to speak today is the DLP technology. Now, the previous technology, LCD, sometimes manufacturers called it also DLP.
Excuse me.
Yes?
Can I
Sure.
stop you? We have some questions about if they can use our resins with their LCD printers, but we will share it in coming slides, like how you can use it and how you can reach our printing parameters, and you will see.
Yes. So we will show you some tips, let's say, on how you can use our resin on different printers. But if we look into the DLP technology, mainly here you have a projector. This is a projector like the one you may use in at home or in the conference room. But the big difference is that it's a UV projector. So the light that is coming out from the projector is a UV light. As you can see from the picture, because the projector is just below the resin tank, there is nothing between, no filter, no mirrors, nothing. So you can reach quite a high intensity power in terms of the light that is coming to the resin. So that's why it can become very fast in terms of curing speed. You can get very high resolution, and also the other advantage is that it's very consistent over time, but also inside the plate. In the past, as many of you may know, Envision started using DLP technologies, but at that time they used projectors that were using as a light source bulb. And the big problem with those bulbs is that after, let's say, a couple of thousands of hours of working, the bulb was running off. Since then, during the last, let's say, 5 years or so, the LED technologies were used as a light source. And by using the LED, you can get really long lifetime. So we are speaking here about a lifetime which is around 20,000 hours. depending on the projector and the LED that is used. On the con side, if I may criticize a bit this technology, and we are manufacturer of this technology, is that the build size remains quite small, because if you want to have very high resolution, what you do is you bring the projector closer to the build plate. So typically in our printer, we have a build size of 133 millimeter, in order to get quite high resolution. So if we wanted to increase the build size, we would lose in terms of resolution. All right. So here, if we use any of these, let's say DLP, LCD, or SLA, but because DLP is much faster, what you can do is, instead of making a mold, you can use those printers to make direct casting. And for that, you would need, obviously, a castable resin. Just to mention you, our 3D printer is called Mega 3D printer. We use projector-based DLP technology. It's a very high-resolution projector. And we use a special technique which is called very fast peeling. Fast peeling means the way that it separates from the resin tank. It's very, very fast. And we can reach speeds that are around 90 millimeter per hour when you cure at 50 microns on the Z layer. So I'll show you actually how fast this can be. We have a
Before we go
Sure.
with this video, excuse me, Mr. Hakan, we have a question that minimum and maximum micron for our Mega 3D printer.
Okay, so on our Mega 3D printer, we have different versions. If you use the build volume of 133 by 75, this is a 869 micron XY resolution. But if we increase, let's say if we decrease the length between the projector and the tank, we have another version, which is a 50 micron version, which has a build size of 90 by 50 millimeter. So we have two versions of it.
I think they are asking for Z resolution.
Oh, for the Z resolution, you can adjust it. We have 25 micron, 35 micron, and 50 micron. But you can also print at much lower resolution if you want. So it depends on you. But most of the prints that we do is either 50 or 25 micron.
Yes, and another question before our video.
Sure.
How much is the projector life, Mr. Raul is asking, and what is the cost for replacing? Okay, so basically the projector has a 20,000 hours life warranty, which means around 3 years of lifetime if you use it on a 24/7 basis. And what you need to replace after those 3 years is not the whole projector, because inside the projector, there is a DMD, there is the electronics and other things. You just need to change the LED. And the LED cost, it's a let's say, powerful LED that we are using. It costs $1,200. So after 3 years, the only thing that you will be changing as a spare part will be the LED light source and the cooler of it. And we, by the way, provide continuous technical support for all our products, because our aim is to basically sell resin and to increase the castable resin volume. So on that case, if you need any further detail, we can answer. Okay, I just want to share this video to show you how fast this can be. Now, what we have done here, we did 4 prints, and with those 4 prints, you will see these are at 50 micron layers. So on the left-hand side, on the top, the first one is we are printing small bowls. That print, full plate, takes 11 minutes. It's 359 layers of 50 micron. Here we have a ring plate, which takes 26 minutes. And the height is around 30 millimeters. We have some pendant here, 41 minutes, and the 2 bangles that are printing on the right-hand side, it takes around 1 hour for the full plates to print. So as you can see, it can become really, really fast. And let me go back to the presentation. Okay, hold on a second. Okay, so what you can see is around, you can print, let's say, 24 large rings in 25 minutes. In average, you can count it like 1 ring per minute. So that makes a really larger production, and you can use such technology for larger production. Here I have other pictures. These bowls are smaller. They print at 9 minutes. And the bangles, the half bangles, so you can print 6 half bangles in 32 minutes. And Can I interrupt you, Mr. Hakan? We have one question which is good. Why don't you use any base for your prints?
Yeah, that's what I mentioned. We use a very fast peeling mechanism, and what we do is on the base, because our watt and the light source is quite powerful, we stick with our profiles quite well, the supports, without using the base to the build plate, and actually you don't need any base to it. Also, the other thing is most of the LCD printers or other DLP printers, they use FEP films in order to keep the resin. And the peeling system is slightly different. The movements are slightly different. So they have some issues that the parts may fall during the print. Now, we never use any base, and we don't have any falling parts issues. We have been studying this over 2 years now. And all the profiles that we give to our customers are made in a way that, you don't need any base. Now, I want to just give you in this table, what can you do with such a printer if you run the printer on a 10 hours basis? So let's say in the day you just work for 10 hours with the printer. You can make 600 rings. That, depending on the ring, obviously, weight, it can be up to 4 kilograms of 20 watt karat gold. You can make of those small balls around 12 kg of 21 karat gold, or if you are running those bangles in a day, you can make, let's say, 2 kilograms of gold per day with one machine. So as you can see, you can really consider this machine as a, let's say, manufacturing 3D printer rather than just a DIY solution. Okay. Now, as I mentioned about the 3D printer technologies, now we will speak a bit about the resins that we can use for jewelry and what our recommendation and the parameters you can use with our resin for different 3D printers. Now, when we started actually 4 years ago doing some R&D on castable resins, the main issues that we have seen on the market is that a lot of resins on the market were not very castable or didn't have good quality when you were casting it. There were some ash remaining, and a lot of people were asking us, but what specific burnout shall I use, or do I need to post-cure, or so on? And we have been working now more than 4 years now on those resin technology, and what we have done is that our aim since the beginning was to make resins in a way that it can cast the same way like wax and have the same quality. So here you have some pictures of our opaque resin. Some of them are 21 karat gold, some is 18 karat, and you have also silver pictures. These are all raw pictures, not polished. As you can see, the casting quality can be really like wax, and I will explain you later on the casting side what you can do on that. Now, these are the various products that we have developed over the last few years. The most popular ones are burn and opaque resin that have been used, I think, since 2 years in the market. We have launched the dark resin, I think it was November. I'll give you some details about it, but it's a much sharper resin for printing. Wax resin is quite used in the US and some markets, also in Europe. It has a waxy feeling, and people like for surface reasons. We have Solus, let's say, resin that we did specifically for the Solus 3D printer. It's a 3D printer that is used also a lot in the US and some in Europe. So it's also a castable resin. And the form resin that we have is for an SLA printer. So that's for mainly phone labs and EWS. We don't only do castable resin, we have also mold resin. The RTV mold resin is mainly used to take silicone dyes, silicone molds. As you can see from the logos below, our main business is selling resin to jewelry market. And we manufacture resin to a lot of different 3D printers customers. So if you have an Asiga, if you have Rapid Shape, Minecraft, or LCD printers like Frozen, Anycubic, and so on, you can use basically all the burn, opaque, dark, or wax resins. And depending on which technology you use, we can, suggest you some of those resins. Now,
I have a question,
sure.
Mr. Hakan.
Mm-hmm.
Mr. Sergio is asking, how is the dark doing in your market? Like, is it selling more than opaque resin, or dark is the best?
Okay, so basically, dark is a new product that we launched, I think, in November, and the reason we did that is that it has a very sharp printing capabilities. So it doesn't do what we call the sagging or the bleeding that you may see in some of the prints with our other resins. It is widely used mostly for stone settings in Turkey. We are selling it also to some other markets. So because it's a new product and people psychologically, they don't like to change a winning solution. So if they are happy with, let's say, burn or opaque, they don't want to change it so quickly. It's not our top seller. The top seller is opaque resin in terms of volume, but it's growing more and more every day, the usage. By the way, if there is any questions, I am not able to follow all the questions, so you may directly ask me to that, because sometimes
yes,
Mr.
Monaraj is asking if all the resins displayed in here are castable, and most of them is castable out of RTV resin. RTV resin is mostly, sorry.
No, go on. Yeah, I mean, all the one on the left outside of RTV are castable resin. Form and Solus are specific resins for specific printers. So Solus is for Solus 3D printer because the light UV profile of that printer is slightly different. And the Form is for SLA, for the laser machines like DWS or Formlabs. But all the other fours are for DLP printers like Rapid Shape, Asiga, or LCD printers as well, like Anycubic or Frontal.
Well, we have many questions here. Let's answer some of them because many of them are according to our resins.
Okay.
Mr. Ravi is asking that we are using PowerCast box resin, but we face some carbon issue. We will discuss this later on.
Mm-hmm.
And Mr. Jamil is asking if dark resin also used for filigree designs.
Yes, actually, I will show you some pictures just in few slides where we have filigree designs. And actually, the funny thing with the dark resin, because it's much sharper, you have around 10 or 15%, let's say, less weight than the opaque or the burn resin, because the details even on the filigree are much thinner or sharper. So if you have, let's say, a filigree which is 0.20 millimeter, in the opaque you may get, let's say, 0.22 depending on the profile you are using, but in the dark you will get 0.20. So it's much sharper, and we have customers using it for the filigree. There is also one resin that I didn't mention here. We may speak to it right now. It's what we call the zero resin, like a Coke Zero, because most of the resins, the castable resins, are shrinking, as you may know. Like any resin has a shrinkage ratio, and we have developed this new resin for to have it very low shrinkage. It has a shrinkage ratio less than 1%, and it's also a castable resin that we are selling in Dubai area, Middle East, and some in India as well. So it's not here because we just did a soft launch on it. We send it for some trials to our customers, and I forgot to put it here. So, but we have another castable resin as well.
One more question: do we use opaque in Anycubic printers? Mr. Abu is asking. We mostly recommend our burn resin for LCD printers. It's because of LCD printers having low intensity of power of low intensity, let's say.
You can use actually opaque as well. Like if you look to the curing profile, I'll give you some examples after. Burn and opaque have pretty similar curing profiles. Dark needs more light or more longer exposure. The color is black and the light needs to pass through it. And wax is actually our fastest curing resin. It cures around 25-30% faster than burn and opaque. So if we speak about LCD or DLP printers, you can use the 4 on the left: burn, opaque, dark, and wax. Okay, let me go through the parameters, and then we can answer, I think, more questions. Now, if you go to our website, powerresins.com, we try to keep all the parameter settings for most of the known 3D printers. Now we have parameters for RapidShape, we have INI files for ASIGA, and some profile settings also for frozen. But what we have seen in the last year or so is that a lot of our customers, particularly for the LCD printers, the light intensity in time of some LCD printers may change or may be lower than expected, or may have some differences between one customer and the other one. So I want to give you some ideas in the current slides how basically you can set up your own parameters. Now, when you think about curing resin, what is important is the total energy that you are giving to the resin. So that means the exposure time in seconds, let's say how many seconds you leave the light open, times the light intensity. So if you have a very strong light, you will need less exposure time. But if you have a very weak light, you will need to cure it at a longer time. The other thing that is important in any printer is the layers, what we call the base layers and the normal layers. Usually, depending on the printers, you have, let's say, the first base layers that are cured at a longer time, so that you can stick the cured resin to the build plate in a strong way. And then when you move on to the normal layers where the ring is starting, there you don't need necessarily so much curing time or so much light. And finally, the other important thing is that every parameters change depending on the resin that you use. As I mentioned earlier, our wax resin is faster curing than the opaque resin. So here I have put a table. On the left-hand side, you have Anycubic. This is an LCD printer. Now, if we were curing, let's say, the opaque resin, maybe you can mark it on it, Tülay, so we can see. If you were curing the opaque resin on Anycubic at 50 micron, the base layers, what you would use is 140 seconds. And for the normal layers, you would need to use 20 seconds. Now, this is, in average, what you expect from an LCD printer because the light is quite low. So every 50 micron layers will remain 20 seconds. If you use our power wax resin, PowerCast wax resin, because it's curing faster, you can reduce the normal layers to 14 seconds. Okay. Now, if you move on to a DLP technology like Minecraft or ASIGA 3D printer, it has a higher intensity. And if we use the PowerCast opaque resin at 50 micron, basically you are speaking about exposure time of 4 or 4.5 seconds per layer for 50 micron, sorry. In our 3D printer, in the Mega 3D printer that we have developed, our light intensity is much higher, and that's why I called it like fast DLP due to the peeling mechanism. And in that case, what you can do is that on 50 micron, we cure our opaque resin with 1.2 seconds. So that's around 3 or 4 times faster than a Minecraft or an ASIGA printer. And if we reduce the layer thickness, so instead of curing 50 micron, which is much thicker than 25 micron, then we can reduce the exposure time to 0.73. So basically reducing the layer thickness will means that you need to reduce the exposure time, but you have twice the layer. So in total, maybe the difference in time between printing 50 micron and 25 micron is around 1.5 hours. It doesn't double when you go to 25 micron. Okay. I want to give you an idea because I mentioned about the light intensity that is difference between the LCD, DLP, or even your own printer. And it's very difficult for all our customers to have a light meter. You know, you need actually to measure the light intensity, a UV light meter. But there is a very easy way to do a test print and to understand if you are putting too much light or too much time exposure or not enough. So we have a file here, which is a small ball. Basically, the advantage of the small ball has very tiny strings. And we know the volume of this ball. So it is 158 millimeter cube as a volume. If you multiply this by the density of the resin, and basically you can get the optimum weight that this ball should come. So it should be 0.180 gram. Now, you can run a test print on your printer according to whatever parameters you put, and then you can clean this part, weight it, and then see if the weight of this part is the correct weight or not. So if it's 183, like in the middle case, then it will be roughly a correct exposure time that you are using. If you put too much light or too much time exposure, you will get an overexposed case where the part will be heavier, like on the right side, 192. Or if you undercure it, then you will have, let's say, 150 or 160 like measurements. We have this file actually, Tülay. Maybe you can share it on the group. You can download this file, and you can, print it after maybe the webinar or in the coming days to check your parameters. I want to show you what happens between a correct exposure and an overexposure. So if you put too much light or too long exposure, what happens is that those little tiny strings get heavier, and that's the difference in the weight that you can check. So this is a very easy way to calibrate your machine or to set up the right parameters. And the good thing about it is that if you have the correct exposure, you will have also the correct weight in resin, but also in gold. So it is very important to adjust your parameters so that you can have the final weight that you expect in the gold jewelry. Okay. I don't know if there's any questions about what we just discussed. I want to mention you here in this slide what happens if you print those balls in every segment of your plate. So let's imagine that you put 28 of those balls on your printer, like 4x7, and you print it everywhere. Now, this is where you see the big difference between, let's say, a professional 3D printer and a smaller DIY type of 3D printer. If the light is quite homogeneous in the whole area, and you give the same light range to the whole plate, what you would expect is to have the same print everywhere on the plate. So this is where, on the top side, what I mentioned is the homogeneous light. So that means we have a deviation of less than 1%. But if you have a printer like, let's say, an LCD printer, but also other printers, where the light in the middle is much hard, let's say, has a higher intensity than in the corners, then the deviation between the prints that are made in the middle and the corners will have a big deviation. Here we have around 8 or 9% of deviation. And that deviation means also gold weight deviation after when you will make the casting. So it is very important that you have homogeneous light, and that there are tricks where you can try to increase your homogeneity by using masking systems and so on. But the best way is to have a homogeneous light at the beginning. That's what I would say. Okay. Any questions, or I continue?
You may continue because I note all of them.
Okay, perfect. Now, about the questions about the dark resin and whether we use it for filigree or not, this is like two pictures of what you can see on the filigree prints. This resin, the dark one, is much sharper. So the filigrees are much thinner, and they are very, very close to the CAD design. So whatever you design, you can get out of this because you don't have any bleeding or sagging. When you are printing, let's say, a T shape, sometimes you have on the bottom some sagging that happens in other resins. We have a little bit of sagging in burn and opaque, and to change that, we have worked on the dark resin. Actually, the big difference is this. So what I mentioned is they use this dark resin mostly for stone settings, because when you design your prongs, if you have a bit of saggings on those prongs and the quality of the print in the prongs is not perfect, the stone settings may be more difficult. So here you can see some example of dark resin and the casting of it for let's say the stone settings. Here on the dark place, on the black prints, all the stones were set directly on the resin by pushing them. Actually, in India and in some markets, there is a technique called wax settings, where you print the part, you don't have specific prongs that are like this, but they are just straight prongs. After putting the stone, manually you can basically add some wax to the area to build the prongs. That's a manual prong settings on the left-hand side that is done with an opaque resin. We have some customers doing it that way, actually.
I have one question just
Sure.
About these prong settings. Mr. Rahul is asking, I couldn't find it, but the question was what minimum prong gap, yeah, that we can do with your printer?
Okay, you know, here people are settings. I don't know if this answers the questions, but you can go to the stone size of 0.8, 0.9, 1 millimeter. This is the most frequent stone size that we are seeing. So the prong gap can be 0.8 or 0.7 or even smaller. And about I believe there is also questions about the minimum surface thickness. Now you can print up to 0.15 millimeter of string of tiny strings and around 0.20 millimeter of surface. But the main issue here is not the printing of it, is mostly the casting of it. So if you have things like 0.20 millimeters large surface, you may have issues in casting because the metal will have some issues to go through. So it needs really skills in terms of casting it. But typically on the market, our customers, they use around 0.30, 0.28, 0.25. Also, if you use, let's say 0.25, let's say you cast it, when you polish the part, you may have also some issues in polishing such a tiny surface. So what I recommend is, you know, if you have a large surface, not to go too much below 0.30. Not for printing reasons, but mostly for casting and polishing reasons. Okay. Oh, another thing which is important, the sharpness of the resin. Actually, it's quite trendy in the last couple of months. We have seen a lot of our customers doing one-piece chains in the market, and they basically design the whole piece of chain, put the casting screw and do direct casting, and then they cut the casting screw, and you have basically a movable chain that, and then you just polish it. This is very handy, and we have seen it quite, you know, a lot of customers now doing that. Now, if you want to make that and you have very, very tiny chains, it is very important that your resin is very sharp, because the empty part where the chain needs to move needs to be very clear cut, so that if you have a bit of expansion in the print, let's say a sagging or whatsoever in the print of a very tiny chain, once you cast, you will not be able to move it because it will touch each other. So that's why also, we recommend a lot the dark resin, or to be sure that you are using the right profile when you make chain.
One question
about
stone settings. Is it important to change designs due to make easier to set stones?
Yes, actually, we have seen that some successful customers, they do prongs that are more rounded shape, not really clear-cut prongs, but mostly round shape, like, let's say, a reversed drop of water. Imagine you have the water drop, but going upward. So, and having two prongs that are rounded, that seems to work much better than the cut, the clear-cut prongs when you want to push the stones or to set the stones directly. Okay, here I want just to mention, but I know most of you, print very well and you don't have any issues in cleaning, but we recommend mostly to use ethanol, ethyl alcohol. We have some customers using for washing isopropyl alcohol, but it is more corrosive, and our resins, we prefer, normal ethanol. And typically you may use 2 containers, one dirty to make the dirty job, and then once it's clean, you put it in the clean. And between them, when you leave it not too long, let's say 10-15 seconds, a couple of times, and you use compressed air to remove, the alcohol on top of the surface. One big difference between our resin and what you may see on the market, and this is related to the chemistry, is that we don't recommend post-curing any of our castable resin. So we have done a lot of tests about it, and post-curing it also may affect the casting quality, because you don't really cure everywhere in the same way. So some areas that are very well cured, much more cured than others, may have a burnout that is slightly different. So what we recommend is let the printer do its job. You have enough strength anyway in the printed parts, so you don't need any post-curing, even for filigree parts. And then you just wash with alcohol, dry it, and then it's ready for casting. Okay.
Well,
any other questions, or we move on for casting?
Yeah,
oh,
I have
see,
some.
I see one question: how to print such large chain links in a single print? Actually, you can put in diagonal. It depends on the length of the plate. We have some customers that are doing them next to each other, and they put half chains and half chains and putting them together, like the one on the bottom or the one on the right hand side. Or we are working, this is from one of our customers that has a version of our 3D printer with a larger build plate. It has a lower resolution, so we are speaking around 80 microns resolution, but a much bigger plate. But he's happy with it, printing it, because of the sharpness of the resin. So you can have around 160 or 170 millimeter plate, but that's a special case. Most of them, they do either in 2 parts, or they put it diagonally or on the plate. All right.
Well, I have some questions.
Sure.
How does non-homogeneous weight of wax affect the final silver gold weight when casting?
So what happens is that if you don't have the same weight of the resin in one corner and in the middle, what this means is that how this weight comes, it means that some strings of some areas are more cured. So you have thicker strings in the one that are in the middle. So if the weight of the resin is more in the middle than in the corner, it means that the one in the middle has a thicker strings or thicker areas that weighs more. When you will cast in gold, what will happen is that you will have the same in gold, and you will have thicker strings in gold, which will weigh more than the one on the corner. And the weight difference is really proportional. So whatever weight difference you have in resin, you will have the same weight percentage difference in the gold. So what I mentioned is you have around 8 or 9% differences in that LCD printer. If you cast the parts that are printed in the middle or the one that are printed in the corner, you will have 8% difference in gold as well.
Which is quite a lot.
Yeah,
for the gold. Okay, one more questions before going through the casting.
Mm-hmm.
What is the difference about weight depending on post-curing? Question.
Actually, if you we don't recommend post-curing, but if you post-cure, you may have some shrinkage or deformation in the print. So what may happen is that the shrinkage of the resin may increase during the post-curing, and depending on the resin shrinkage, let's say ratio, you may have, what happens is that the ball may become much smaller because the parts, let's say the polymerization increase, and you have a shrinkage issue. So, and because you have a smaller piece after post-curing, then it means that you will have obviously a smaller piece that is casted. This doesn't mean you will have at the end a less weight, maybe let's say 3%, 5%, whatever it is, but the size of the ring or the size of the ball will be smaller as well. So that's why you have less weight, and it's not something we recommend, because we want to keep as much possible as to the CAD design. So let's say if you have a ring size 18, you want to keep it 18 after casting as well. You don't want to post-cure it and make a huge shrinkage and then have the size of the ring reduced and then have a smaller ring at the end. Okay.
Let's carry on more about questions, because I have a good question again. Mr.
Sure.
Jamil is asking, which of your resins is the best for flexible chains?
As I mentioned, for the chains, we recommend the dark resin because of the sharpness. So this is the most used one at the moment. I know in the pictures they were opaque and so on, and these were the first tests that we made with that customer a couple of months ago. but on the chains, because of the sharpness, you will have, I would recommend the dark resin.
And Mr. Harish asked that, like, how to print such a large chain links in a single print?
Yeah, I answered that actually. So basically, it's depending on your printer build size. It's totally depend on the size. So if you put it as a diagonal for our printer, or we have a version which is slightly larger, you can print it. It depends on the size of the. Obviously, if your chain is, let's say, 180 millimeter, and you have a, small 3D printer, 120 millimeter, you cannot do that. Or you need to do in two parts. You split the chain in two, and then you do, laser welding between the two chains. That's something you can do. Okay. I see questions about the shrinkage, which I want to answer. What is the average shrinkage in dark resin? Now, the shrinkage of dark resin is like the opaque or the burn resin, depending on how you print. If the profile is correct, how you store it, you may have a shrinkage of, let's say, between 4 up to 6, 7%. Now, there is a way to store the prints so that you don't have any shrinkage. Now, what you need to understand is that the shrinkage happens once you wash with alcohol. If you don't wash your parts, there will not be shrinkage. So what I recommend to some of customers that want to cast the next day or in 2-3 days, don't wash your prints. Just print. Keep your prints in a box in the dark, and then just wash it before casting if it's possible, a couple of hours before casting. In that way, you will reduce a lot the shrinkage ratio. The other thing is, let's say you washed it, but you want to cast it the next day anyway. I recommend to keep it in a plastic bag on a sealed so that there is no air coming into it. This is the ratio that we have on the shrinkage, whether it's dark, opaque, or burn. If you want a very low shrinkage resin, we have the zero resin that I mentioned earlier, and the shrinkage on that is less than 1%. So on that resin, you can basically you can have less than 1%. Okay, maybe we continue on the questions at the end. I just want to go through the casting, if that's fine.
Yes, sure.
Okay, so a lot of questions about casting is, which burnout cycle shall I use, which investment, which casting machines, do you have ash remaining, and so on. Now, about this, very briefly, first thing that I want to say is that resin is not wax. So the big difference is that if you have a wax piece and you burn out light on it and you heat it up, it will melt and will drop. But because resins are thermosets, so that after the polymerization, you don't have a way to go back to the initial air stage like a candle, it doesn't really melt, but when you heat it up, it becomes gas. So that's a process called sublimation. So from a solid state, it becomes a gaseous state. This is a very important difference. The other thing that I want to tell you, after 550 centigrades, our resins, they finish their burnout. So we will see about the burnout later on, but keep in mind this. So 550 centigrade Celsius is important for us. Now here I've put some different competitive resins in a kiln oven. And when you heat up, you can see the gas that is formed on the left-hand side. And on the right-hand side, you can see the remaining ash that remains for some of those resins. So those little ash that remains, it means that the burnout, even if you go up to 800 degrees, still remains and you have still some ashes. Now, I don't want to say that all our resin are 0% ash. We say it's almost ash-free because we have a very, very low percentage. And also, we know that because of the gas formation inside the flask, because the gas is pushing our resin, the remaining very small ash actually goes out very, very easily. So we have such a low fraction of ash that you don't really see it after casting. That's how we get most of the good surface. Another thing that happens, if you take your resin and put it in the investment, now during the burnout, there is the investment that has some reactions, cristobalite reactions and so on. And also the investment may react also, the investment may react with the resin. So what you need to consider is, what is the reaction of the resin you are using with the investment? And another big important fact is most of the resins on the market, they have a quite big expansion rate. So when you burn the resin, it's kind of making bubbles, or it's expanding. On the left-hand side here, you can see a flask where we put a big part of cured resin, where it cracks basically the flask because of the expansion. And on the right-hand side, you can see one of our resin where you don't have expansion. Now, if you don't put a big part, let's say a huge, I don't know, let's say this mug, if you don't put it in the flask, you will not see these cracks happening, but you will see the cracks happening inside the investment, on the little details and on the little surfaces. And on this right pictures, the two of them, we have shown you here a small ring, which is a Harley-Davidson ring with some engravings. If the resin has expansion, what happens is that it's going to break the investment while burning out. But if the resin doesn't have expansion, the engravings will not be broken. So it is important at that stage to choose well your resin that has really low expansion.
May I stop you here?
Sure.
Is just a question from Rodney.
Okay.
Are you recommending adding boric acid powder to casting plaster?
Okay, that's a very good question.
And which plaster are you recommending?
Okay, that's a good question. I am following a lot of forums online and so on, and people tend to use boric acid in the investment so that it becomes harder. And it is important for most of the other resins, I believe, to have a hard investment so that you don't have this expansion or this breaking issues. But for our resin, actually, we don't recommend any boric acid because we don't have such a expansion issue there. So most of our customers in Turkey, in Middle East, or in India, they don't use any boric acid. And we don't see any difference whether you use a boric acid or not. The other thing is, I want to mention about the cycle and how to manage it. As I mentioned, resin is not wax. So when you follow what we recommend, we don't recommend a particular cycle. We don't recommend any particular investment. We have customers that are using, Optima or various different of investment, Omega and so on. So what we recommend.
Here,
yeah.
Yes, right here, this is the question. What we can recommend to use for investment the best?
Actually, you can use a lot, but okay, we have customers using Optima Prestige. We have a lot of different investments that are used, CRS in Russia and some other investments in India. It's good if you have a hard investment, but to make the investment hard and to have the right casting on the investment, what we really recommend is to follow the instructions and to follow it much more carefully than if you were casting wax, because as I mentioned, it doesn't melt like wax. So what you need to care about is the water powder ratio, and try to leave the flask outside between 2 to 4 hours or even longer to make sure that it removes the water in it and it gets enough hard before putting in the oven. You may not care about that when it's a wax casting, but for resin casting, you will have much better surface. So I strongly recommend following the recommendation from the investment, specs, and typically to use a harder investment is always better. With our resin, because we don't have such an expansion issue, we don't necessarily need a special investment. And also, as I mentioned, after 550 degrees, in our case, we don't have any remaining things to burn. So the whole burnout process is finished. So whether I've put here an example of a cycle from one of our customers. There is a step here that goes to 550 centigrades and then to 780 centigrade. Now, you don't need to keep that 780. You can make it 720, 750. It doesn't really matter for the resin. It matters maybe for your casting or for the investment. So what I recommend strongly, follow the investment, which, by the way, we are planning to have a webinar in the coming days about only casting, and not just casting our own resin, but also casting wax. That I will mention later on. This will be with our somebody from Dubai. and he's quite expert in casting. He works for Topcast. So we are planning to have another casting cycle.
Mr. Dipansha.
Yes, that's correct.
Yeah.
I couldn't remember.
I have one good question from Rodney again. He's saying that 99% of all casters seem to have the biggest issues with casting seems to be from inefficient resin curing. What's your advice?
Okay, this is about post curing, I believe. Now we don't recommend any post curing because there are two types of resins in the market. You know, most of the other resins that you see on the market, they need post curing first of all for casting, but also for having enough strength to hold the piece. It's in our case, the resin already have enough polymerization. It's enough strong to keep it, and you should consider it like that. What happens when you print? Basically, at 50 micron layer that you open every time, let's say 1 second or 5 seconds, whatever the printing profile has, is that you have a perfect curing of all those 50 micron layers. Now, imagine you have the ring that is perfectly cured every 50 micron, and then you take this and you put in a post-curing chamber where some areas will be post-cure more than some others. So some surfaces will be most cured than others. Why this happens, why you don't need post-curing in our resin than other resin? This is totally based on the chemistry of our resin. This is also based on the fact that our resin burn out, let's say, at a lower, starts burning out at a lower temperature than some other resin. And also the fact that the part has already pretty much done. Let's say the printer has already cured most of the parts already, so you don't need any post-curing. I don't know if I answered the question, but maybe if there's anything I'm missing, please write more details.
There is many questions. It's really hard to follow. But
Okay.
the one question which is also frequently asked to us, like how should I cast in diamond? Like which cycle, which investment? As far as we know from our customers' experiences, that you need to use a special investment for diamond in casting. And obviously, we recommend to follow instructions, what is written on your investment powder. But maybe after this webinar, we can recommend you some from other users' experiences, like the brand that they used and they had a good result.
Yeah. One thing I want to say is I'm seeing Mr. Ashraf that apparently had some issues in casting.
Many questions I cannot follow.
If you have any issues about casting, I will send you some of our contact details. Now, it's important that you send us what you have done, how you have casted, and whether you did post-curing or not, how you washed it, and send us some pictures. And really, we are here to help. Like whether you have a 3D printer from us or not, doesn't matter. If you are purchasing any of our resin, we want to help you. So, but I can tell you that the fact that we were successful in the last 4 years, whether in Turkey, Middle East, India, or even in Europe and so on, it's because of the very easiness of the castability of our resin. But please send us any questions.
Also, many people asking about like which investment and which casting machine did we use to have these casting results?
Okay, these are from one customer. They are using, actually they are just sending to a casting house. This casting house is using Induterm. We have customers that are using Topcast, and we have also some customers using Yasui. So in that sense, if you have a proper vacuum casting machine, you know, for the resin, it doesn't really matter because the resin burnout is finished after 550 degrees. What is important is how you manage the gold and how do you have the proper pressures? Do you have the proper melting temperatures and everything so that you put in the flask the gold? So the job of the resin, of our resin at least, is ended at 550, 600 degrees. After that, the whole process after it is you have a flask with emptiness and how you pour the gold with the right pressure and the right temperature. Obviously, if you have very tiny filigree, which is like 0.25 or surface like 0.25 or 0.30, you need to be careful about the pressure and the temperature. If you have too low temperature, your metal will not flow enough, and if you don't put enough pressure, again, the metal will not be going everywhere. And finally, you need to care about how you put your screws, depending on the size flask, on the flask size. So I don't see, this is a big question. A lot of customers is asking us which machines they are using, but really maybe we have customers that use maybe 10 different casting machines. We have also customers doing spin casting. So I think rather than focusing on the machine, and in the next days with we will have a special casting webinar. The machine is important, but I think what is more important is what is the investment powder water ratio you are using. Are you doing everything properly in the whole cycle? And then see if you have any issues on the pressure or on the temperature with your machine.
Yeah, there is many questions about casting, but let's keep them for our next webinar. It will be all about casting with the like Topcast reseller, which is like already selling casting machines and having deep information. I'm sure we can discuss in that.
I want just to go through very briefly. I know most of you, do a lot of support for resin-based 3D printers. So as you know, if you are printing a ring, you cannot just put it in a DLP printer like that. You need to add supports. And actually, we have, maybe you can share today, we have on our YouTube page, we have posted a lot of training on how to best support. But I just want to briefly give you here a few tips on the best way to support. So first of all, we in-house, when we support things to test models and so on, we use Rhino 3D with the Bell Support plugin, but you can use Matrix, you can use various different tools. In our software of Mega 3D printers, there is also an auto support function, but we ourselves don't use it frequently. It's very much used in dental because it's easy to put supports everywhere. But for jewelry, you want to know where you put the supports and to design the parts so that it's easier to polish or easier to clean after casting. So I just want to give you here some ideas on supports. Here you have a bowl where we put straight line supports. On the middle side is interesting. We didn't support too much the main part, but we use the casting screw. So we have some supports on the bottom. And on the right side, we have a filigree part where you have some supports. Actually, there is a base there, but we don't need it for our printer. That's for other printers. And we also put a sort of oxygen bowl where you can see in the middle of the ring, so that there are some people that said that this oxygen bowl area makes the casting better, so that the flow of the oxygen is easier during the burnout. And also it helps the metal to flow in. So that's something sometimes we do just to join the various supports. Now, how do you find the areas where you need the support? This is a technical question, and I think we can have a session about support as well in the coming days, where we can try to support different bangles and rings or chains. But typically the easiest way is to think like the machine. Let's imagine you draw a planner on your ring, and you bring every 50 micron upward, upward, upward. So when you do that, you will see how the printer is printing on every 50 micron layers. And as shown on the right-hand side, thank you, Tulay, for drawing that. As shown on the right-hand side, you can see the parts that needs support. Why? Because these are on the next layer, the parts that will be built with the printer. But if you don't have a support from the bottom or from somewhere, these parts will be falling. So you need in that particular ring to notice these small areas and to put a support there. Now, depending on the orientation of your part, you may need more support or less support, and we all know how to manage depending on the type of the ring. I want to just ramp up about the support. I recommend usually to put also a casting screw. You can either don't think about casting, and a lot of designers, they just draw the part and then they give to someone else, and that someone else is just putting the support, and then that part is printing with another operator, and that person is printing it, washing it, and then it's casted from another operator. And the designer or the person that is doing the support, I think, needs to be aware that we are going to cast this part. So it is very handy to have a casting sprue when you design the support. And I like very much the example on the right side, because there we have designed a casting sprue, but it is also a support for the part. So it is not only a casting sprue, it is used for casting, but also to print the part. So that's something you can consider. On the left-hand side also, you can see a casting sprue for the parts, and on the right-hand side, the whole casting sprue. Okay?
Yeah.
All right. Just a few mistakes that happens that we have seen on the market. Now, the logic of supporting means that you want to support the part, okay? You don't want to support something else first. And also the logic of casting sprue is that it needs to bring the metal to the main part. Now, I have shown in the middle or on the right-hand side, first of all, on the middle, there is a big problem, is that if you look to the supports, they are very long and tiny. So if you have a very long, tiny strings, like the one in the middle, what will happen is that they will shake during the print. And the longer the support is, the thicker it should be. So you need to think about a different way of supporting such part. The other mistake that you see in the black dot circles on the middle or on the right-hand side, the part is in the middle. They did a casting sprue around, but actually the part is supporting the casting sprue in that case. So you have the part that is used as a support for the casting sprue on the top, where you don't need that part of the casting sprue. So when you build casting sprues, it should be mostly on the bottom of the part, let's say, so that it's used as supporting the part, and also you shouldn't use your main part as a base for something else, which is in that case the casting sprue. And finally, on the left-hand side, I just want to mention two parts that are the same parts, and in the middle there is a very flat surface. The one on the left has a bit more supports, and because there are some supports under that flat surface, you can see that there is no deformation in that part. Where the one on the right, because there are some missing small supports, there is that, let's say, very tiny leaf that during the print is shaking, and because there is no supports under, it doesn't hold, and you have this deformation. So that's, I think, some interesting mistakes or let's say tips for supporting. Okay, I already mentioned you that we have our YouTube channel, but I believe we will do also a webinar just about support. So if you have, if you want to follow, or anybody from, let's say, because I see there are some large manufacturers here as well, anybody from your technical team that can join those webinars would be interesting. You can go to our YouTube channel. I don't know if you have shared it, July, but
yeah,
you can
already shared.
All right, so let's ramp up and then have some question and answers. Our next webinars will be based also about one specific webinar just about casting with Mr. Dipen Shah from Topcast Dubai. And I didn't want to mention it here, but we have launched recently a new jewelry design platform. It's called Nova Platform. And we are planning also to demonstrate in a live webinar how this platform is working. But the main idea is there are a lot of designers in Turkey and abroad that design for our customers. And this enables you to have the possibility to use those designs. You don't actually download the STL, but the designers gives you access to print with our Mega 3D printer all those designs. And there are more than 3,000 designs in this platform. And every week we are adding new designs. So we have some customers, let's say in India or other places, that use ready-made designs from Turkish designers or other designers, and they can just click on print and print those designs. So we'll have those two webinars in the coming days. I'm planning, hopefully, to have webinars about support, and please let us know if you want, any other topic webinar that we can discuss more as well. All right, so let's go through some questions and answers. These are our websites. Here you can see some WhatsApp numbers if you want to share us pictures about your casting or your printing. Our Facebook page, Instagram, and YouTube page. And I think we ramp up a bit. I hope it was interesting. Please, let's answer some questions if you can see some today.
Yes, we were thinking if we need to have another webinar for just question and answer. I think it looks very convenient because we have many questions that are really hard for me to follow up. But there is one question for short cycle. Did we mention about this?
Oh yeah, I forgot. Actually, yes, we have some customers. A lot of them, they use actually a shorter cycle. Typically, they would go up to 750 or 800 Celsius in a 4 hours cycle, and then they will cast. So you can do that. Depending on the size of the flask, the cycle time can be different, but you can definitely do that. I'm seeing also one question from Rodney. Will the ready-made designs already be supported for printing? Yes, they are. I think he's mentioning our platform. Actually, the whole designs have already casting screws. They already have supports. The customers, the manufacturers, what they do is they just select how many of those rings or bangles or whatsoever they want to print. And actually, the fee part of it is not a download STL and print system. It's that the designer gives access to print, let's say, the amount that the customer is requesting. And the customers is paying on a per gram basis on the resin gram. Is a small fee, much smaller fee, but they will pay every time they print, basically. So it's on a print pay. The system is not a download STL data model system. And
yeah, we will go deeply in the next webinar. So now I have one more question, which is a good question. Do you recommend to turn the flask up and the end of the burnout cycle?
Okay, that's something as well. We did a lot of trials about that.
Yeah.
To be honest, I don't see any difference. Now, we have some customers doing it, some customers don't do it. But after when we worked out on the chemistry, if you consider, typically they would turn the flask when you are around, let's say, 700 or 750 degrees. But as I mentioned earlier, in our case, in our resin, the job of the resin is finished. Everything is burned out and is pushed out with the gaze around 600 Celsius. So you don't, whether you turn it upside down or the other way, the oxygen with the gaze effect, and because you don't have pretty much ash, is going downward or upward, doesn't make a big difference. I haven't seen statistically difference in the whole casting that our customers are doing. And trust me, Turkey is a good hub for casting. We do a lot of casting here. You know, I didn't mention in this presentation, but in terms of the world manufacturing of gold, Turkey and Middle East is around 10%, and India is around 1/3, and China is around 1/3. So, you know, it's very, we have a lot of customers casting on a daily basis, maybe, let's say, 500 rings or 1,000 rings. And when I look to the whole casting process of those large casting houses in Istanbul or even in Dubai, customers, or in India, the thing of turning the flask doesn't make a difference, in our opinion. Maybe it does for other resins, but for our resins, we haven't seen that.
Sorry, it's been almost 1.5 hours. I think sorry all of the attendees for the ones that we couldn't answer their questions, but I will get back to you in person after this webinar, and maybe we can plan the next webinar like in 2-3 days for just question and answers. Like you can ask all the questions you have and we can answer, maybe, I don't know.
Mm-hmm.
And
let's make like that. I think I know I see a lot of questions and it's difficult to follow, but one thing that we can do is, first of all the questions about casting, please follow our social media accounts. It will be in a couple of days. I don't have the exact date, but we will have just one session about all the casting questions. So with Mr. Dipat, that's one side. About the platform, we will have also another webinar just about the platform, so the way it works and how easy or difficult. I mean, it is very easy, but you will see that. And maybe we can do also after that, or maybe before, just a session where we don't have major presentation, but a Q&A session. Like you ask everything. We can also invite some of our engineers and just, question and answers. That can be also interesting.
Yeah, because there is mostly technical questions and in details. And
one question,
the best way.
That is, how much is the price of your printer? Like that's also, it's $24,000 actually, but you can directly contact Tülay and all the other guys. Thank you for all. I see that, there is quite a good number of attendees. I hope the time also is good. It's 7 p.m. in Turkey. We try to make it in a way that it's still okay for India and for the US as well. Please give us some feedback, whether on WhatsApp or by email or whatsoever, so that we can adjust and make it better. Sergio is saying,
my last question is here.
Yeah, sorry, let me take that. Is the platform working or is it not still? Actually, the platform is working. We launched it last week. We have already some customers using it in some areas. Yeah, we didn't do a big launch on it because we wanted to have some demo customers. But the technology behind it has been used in some customers over a year now. And we have launched our websites. Yes. By the way, this is a website that is only for members. So it's not like a website where you just register and can see all the design and choose. You need to have our Mega 3D printer. And then you can basically print all the files that are there. And you need to be a member. We don't have a membership fee, but you need to be a member of it. Okay.
Okay, we can say thank you for everybody. Like it's been very enjoyable for us, and it's quite excited because there is too many attendees and too many questions. Hope to meet you soon. Let's say your last sentences, Mr. Hakan. And
no, I'm very happy actually. I feel very close to most of those attendees because I know some of them in person. I hope to meet you very soon, whether in India, in Lebanon, in Russia, in US or whatsoever. By the way, the Istanbul Jewerly exhibition was obviously postponed due to the coronavirus. We were a bit sad about that, but they are expecting to make it hopefully by the end of June. And if you want to attend, you are more than welcome. And I would be very happy to meet you all very soon. So hopefully it will end soon, this these tragic events. Thank you very much for all.
Hopefully.
Okay. And let's catch up in the next webinar.
Yeah, lastly, let me share all of our social media accounts with you to follow up for our future webinars. There is a...
Yes. In the meantime, I can take last question from Mahmoud. He's saying, are you going to produce a new larger 3D printer? Our R&D is working on it. Yes, we have worked a lot. Actually, the Mega printer, we have one version, which is a larger version, like the one that I mentioned. But you lose in terms of resolution. So the optimum 3D printer that we recommend is the one that we have now, the Mega 3D printer. And it's 133 by 75. We have a version which is 90 millimeter by 50, which has much higher resolution. And at the moment, these are the two versions that we have. Our R&D is working. We hope by next year to have larger build size also, but it doesn't necessarily depend only on us because some parts inside the projector, the DMD that we are using, it's made by Texas Instruments, and there are some restrictions there. So we cannot just increase the build size depending on what we wish. So hopefully that's it. Thank you very much.
Thank you very much for joining.
Okay, thank you. And hope to see you soon in the next webinar.
Keep follow us for the future webinars. Thank you.
Thank you.
Thank you.